In the 1961 issue of Space World, Dr. James Van Allen stated, "A living organism cannot survive this level of radiation damage. Hence, all manned spaceflight attempts must steer clear of these two belts of radiation until adequate means of safeguarding astronauts has been developed, and that, owing to the great penetrability of the high-energy protons therein, effective shielding is quite beyond engineering feasibility in the near future. Hence, the inner zone must be classed as an uninhabitable region of space as far as man is concerned. The outer zone is much more difficult to avoid." Are Van Allen's claims of killer radiation true?
I'll take a moment with this one. First of all, congratulations. I think that's the most recent article you have ever quoted Van Allen from. That was, what, 2-3 years after his original discovery of the Van Allen belts, when still relatively little was known about them.
False. If you are going to claim to be an expert on aerospace history, try showing knowledge of such. It is commonly stated that Van Allen's discovery of the radiation belts was in 1958 with the Explorer 1 satellite. This is not entirely true. The first detection of the radiation belts was as early as 1952, back when Van Allen was sending up raccoons into space. These did not have enough power to get into orbit, but they made it high enough to encounter radiation levels higher than Van Allen had anticipated. Yes, years later he would put Geiger counters in the Explorer satellites. When Van Allen made this statement, he had thoroughly mapped the belts with the Explorer satellites and Pioneer probes, not to mention the Sputnik satellites and lunar probes, whose Russian owners happily shared their data with Van Allen. Van Allen stated that adequate shielding of manned spacecraft had not been developed. When he made that statement, both the Americans and the Soviets had made 2 manned flights. The US with Shepard and Grissom, and Russia with Gagarin and Titov. Just like Apollo, Mercury was a lightweight capsule that could only operate with a low-pressure, pure oxygen atmosphere. The Russians since Vostok through to Soyuz have always had the luxury of flying in a sea-level pressure, nitrogen-oxygen atmosphere, hence the need for thick walls to contain it. If not even the superior-hulled Russian capsules could offer adequate shielding, how could the lightweight American capsules possibly offer adequate shielding?
He remained very active in space exploration for another 25 years. How come you don't have any more recent quotes than this?
I do show more recent statements, such as E. E. Kovalev's 1983 article and John H. Malden's book.
Like his much more recent response to hoaxers, in which he states that claims like yours are nonsense.
Unlike you, I have no need to quote mine. You obviously don't watch my videos much. I do show this statement. It's difficult not to, as Rene made no secret of the fact that he was in communication with Dr. Van Allen.
The original Geiger counters had been overwhelmed by an enormously high level of radiation. Subsequent to my writing the book, he retracted. Gee, I wonder why. Ain't that strange? And I used to write him and say, look, for Christ's sake, you're getting older by the day. You want to die with this shit on your conscience? And now he says, well, maybe we made a mistake. Geiger counters don't make mistakes. Geiger counters don't make a mistake. They sent up one Geiger counter, and the further up it got, the radiation picked up right away, and it kept getting more and more and more, and then it shut up. And they couldn't understand that. Finally, some guy on his team says, hey, let's take another one, and let's shield it to the point where it starts, where this one quits, and see what happens. They did that, and I never did find out where the second one quit, or if it didn't quit. But one is enough to know you're in hell. What the hell do you think they make the friggin' things for? Imagine it bypassing one and going into a second one. But that's not deadly radiation now.
In any case, thank you for supplying us with this letter. As you can see, it offers no reconciliation for the readouts he got from the Raccoons, Explorer, Pioneer, Sputnik, and Lunar spacecraft. In fact, he doesn't even mention these experiments. Any newbie reading this letter would think he never made those claims to begin with, which pretty much confirms what I've been saying all along. He swallowed his words and offered no explanation for why his readings told him the radiation was deadly. Why should I take as gospel a statement made by someone that offers no reconciliation whatsoever for what he previously stated? Do I trust the murderer's "I didn't do it" claim when he previously confessed to it and even provided the murder weapon? If you want to hear the only modern statement that Dr. Van Allen ever made on his original work, read the October 1997 issue of Media Bypass.
Professor James A. Van Allen, now 83, is Professor Emeritus in Geophysics at the University of Iowa. Our first question was why he did not speak up after NASA's claims and defend his original findings. Astonishingly, he told us that his seminal Scientific American article in 1959 was merely popular science. Are you refuting your findings, we asked? Absolutely not, he answered. I stand by them. In the next breath, Van Allen acquiesced to NASA's point of view. He became positively mercurial in his answers. Basically, he defended NASA's position that any material, even aluminum without shielding, was adequate to protect the astronauts from the radiation he once called deadly. When we asked him the point of his original warning about rushing through the belt, he said, "It must have been a sloppy statement."
So, you stand by your original statement, yet you call your statements about deadly radiation sloppy? Where's the logic in that? Considering the results of many satellites, space probes and raccoons that Van Allen sent into the belts, not to mention the results from the Soviet missions that confirmed the American results, and the fact that modern satellites must operate outside the belts to protect their instruments, are we to believe that all of these results were merely a sloppy statement?
Anyway, since there was a measurable risk, that's why the Apollo missions were planned to skirt around the worst parts of the Van Allen belts. But you already know this, don't you?
The idea that one can avoid the radiation of the Van Allen belts simply by steering around them using the trajectory that Apollo allegedly took seems to have gained popularity within the propagandist crowd. So it's worthwhile spending some time with this one. Yes, the belts are thinner towards the poles, and there is less radiation there, but it's still far from safe. As Kovalev tells us in his 1983 article, the dose rates at the equator are 11,666 rem per hour, and this dose rate decreases towards the poles to be as low as 312.5 rem per hour. But 312.5 rem per hour is being generous to the Apollo astronauts, as this dose rate applies to astronauts on a ship with an inclination of 90 degrees. American spacecraft usually launch with an inclination of about 30 degrees, in which case the dose rate would be 667 rem per hour. In case anyone tries to deny that Apollo's alleged trans-lunar trajectory had a 30-degree inclination, let's remember what Windley wrote on his site. Each mission flew with a slightly different trajectory in order to access its landing site, but the orbital inclination of the trans-lunar coast trajectory was always in the neighborhood of 30 degrees. Stated another way, the geometric plane containing the trans-lunar trajectory was inclined to the Earth's equator by about 30 degrees. A spacecraft following that trajectory would bypass all but the edges of the Van Allen belts. Propagandists don't deny that astronauts would have taken an hour each way to pass through the belts. Given that the maximum doses of radiation one can receive before dying is 500 rem, that means the astronauts would receive 1,333 rem, or 2.6 times the lethal dose in the belts alone. Hopefully, this puts the 30-degree inclination trajectory argument to rest. Was Van Allen correct when he said, "The discovery is of course troubling to astronauts. Somehow, the human body will have to be shielded from radiation, even on a rapid transit through the region."
And so they were.
No, they weren't, as I pointed out earlier. Astronauts astrophysicist John H. Malden writes that aboard a spaceship with 2 meters of water shielding, the doses within the Van Allen radiation belts will be reduced to 1 rem per day, or 0.041 rem per hour. Is this true?
I'm sorry to have to disappoint you again, but I'm not qualified to answer that question. Nor do I know the context in which it was made, or its relevance to the Apollo missions. Now, if he was some hero of mine, or if I had made dozens of videos pushing his ideas, then you might be justified in asking me.
Unlike you, I have no need to quote mine.
That's a pretty nice collection of space exploration books you've got there, Jarrah. Why don't you sell them to someone who can appreciate them?
At least you admit that you are not qualified. And since you ask for the context, here it is. John H. Malden proposes a starship with 2 meters of water shielding, surrounding the living quarters to protect its occupants from solar, cosmic, and also belt radiation. Naturally, his theoretical moonship would need to traverse the Earth's radiation belt and the radiation belts around the other planets belonging to the stars they would visit. On a starship, there are many ways to receive low or high doses of X-rays and other radiation. Any nuclear reactors, fission or fusion, radiate those who must work near them and those near the shielding. Planets with magnetic fields have belts of trapped energetic particles that must be traversed to leave or reach the planet. Near Earth, the dose is about 1 rem per day. Some stellar objects, unlikely to be visited soon, emit intense energetic radiation. Solar or star flares of protons, an occasional and severe hazard on the way out of and into planetary systems, can give doses of hundreds to thousands of rem over a few hours at the distance of the Earth. Such doses are fatal and millions of times greater than the permitted dose. Death is likely after 500 rem in any short time, whereas 500 rems spread out over a lifetime is not likely to cause trouble, although is not clearly safe. NASA has suggested astronauts might tolerate about 200 rems if received over several years. While cosmic particle radiation provides less total dose, the higher energy can cause many kinds of secondary particles flying through the starship after the primary particle is stopped by thick shielding. Cosmic particles are dangerous, come from all sides, and require at least 2 meters of solid shielding all around living organisms. Earth's atmosphere provides the equivalent of 10 meters of shielding. By comparison, solar flares can deliver GeV protons in the same energy range as most cosmic particles, but at much higher intensities. Increase of energy accounts for most of the increased radiation danger because GeV protons or their products will penetrate several meters of material.